or quantity of drug rather, sorry. All right, let's look at number 12. How many milligrams of ketorolac are contained in 1.7 ml? .75 ml. So we know we're searching for quantity of drug, so that is going to be our X. The desired dose is 1.75 ml. Now we need to look to our prescription label to see, and it reads ketorolac, tromethamine, 60 milligrams per 2 ml. So 60 milligrams, we know that milligrams is going to go on top because that matches up with our unit of measure. And 2 milliliters on the bottom, and now we can solve for X. These are going to cancel. 1.75 times 60. The milliliters are going to cancel. And X is going to equal 52.5 milligrams. Okay, let's do one more of these before we move on to looking at some ratios. Let's look at number 13. How many milligrams of lidocaine HCl are contained in 3.75 milliliters? Okay, so again, we're looking for milligrams as our variable, so that's going to be our X. The desired dose, 3.75 ml. So let's look at our prescription label. And it reads lidocaine HCl 2%, and it's 20 milligrams per ml. And usually when you're looking for these, those are almost always going to be in parentheses next to the strength of the drug. Okay, so now we've got a proportion we can solve for X. This is going to cancel. The milliliters are going to cancel. 3.75 times 20 divided by 1, and X is going to equal 75 milligrams. Okay, so let's turn to the next page and look at number 21. We're going to look at some of the ratio solutions, and these are the ones that look slightly different. How many milligrams are in a 2 ml of a 1/1000th solution? Okay, so what we're looking for again are milligrams. So we know that that's going to be X. And it's a 2 ml solution. And then if we look at the drug, it's written as a ratio, but we know that 1 represents 1 grams and 1,000 represents 1,000 milliliters. Now, here's our problem. Our units of measure need to match up. In this case, grams is what's represented. So for the time being, we're going to need to solve our X for grams, and then after we find that, we can convert it to milligrams. So let's go ahead and solve for X. Times 2, the milliliters are going to cancel out, and X is going to equal 0.002 grams. Okay, but we want our final answer to be in milligrams. We know that that is 3 decimal places away. So X equals 2 milligrams. And we just need to convert it. All right, let's do 1 or 2 more. The big thing to remember when we're doing these is that if the units of measure don't match up, you're going to have to solve and then convert. Number 22, how many micrograms are in 1 ml of a 1/5000 solution? Okay, so we want to solve for micrograms. That's going to be our X over 1 ml, desired dose, and then the available quantity We know that 1 stands for grams. These are always in the base, the units of measure, and 5,000 is going to be in milliliters. So of course, we have our issue. Grams and micrograms do not match up. So for the time being, to solve for x, we're going to have to solve for grams and then convert to micrograms. So take this times 1 ml. These cancel out. The milliliters cancel out. And then 1 divided by 5,000. And x is going to equal 0.0002 grams. Okay, but we're not done because we still need to convert that to micrograms. Now we know that grams are 6 decimal places away. And we're moving to the right. So 1, 2, 3, 4, 5, 6. We can get rid of these. So it's x equals 200 micrograms. Most important thing, remember, checking your units of measure to make sure they line up. If they don't, you're going to have to change them and then convert after you find what x is. Okay, let's do one more. Number 23. How many micrograms are in 1.5 mil of a 1/10,000 solution? Okay, so we were solving for micrograms. The desired dose, 1.5 ml. And again, this is always going to be in the base, so we know that 1 stands for grams, 10,000 stands for milligrams. So again, we have the issue that our units do not match up, so we're going to have to solve for grams and then convert after we figure out what x represents. 1.5, these cancel out. Milliliters cancel out. 1.5 times 1 is 1.5 divided by 10,000 gives us 0.00015. And that's in grams, so we're not done. We need to convert to micrograms. So grams are 6 decimal places away from micrograms. So 1, 2, 3, 4, 5, 6. So we know that x equals 150 micrograms. Okay, so hopefully that has helped clarify. Reading prescription labels, you're going to have to look at them close. That's the most important thing to remember with that. You can still use the ratio proportion method or the dimensional analysis method, whichever you prefer. And then in calculating ratio strength, remember it's always going to be represented as a ratio in its base form, so you're either going to have to convert it after you solve for x. If you have any questions, feel free to post them to the discussion board, and good luck finishing the rest of the practice problems.